All right, we only got one more. Yay! This should be way easier. Way easier. Um, basically, we just need to find determinants of stuff. And the way I'm gonna do this is the last one, and the easiest and by far quickest way to do this is let's write our augmented matrix out. So the first, there's four matrices that I really care about. First is the actual regular A matrix. So that's going to be 2, 5, -1, 4, 9, 7, -2, -4, -3. Okay, so that's this stuff here. Then the matrix, I'm going to say A in terms of X. This is where we're going to move. We're going to switch the X column with the target. So we're going to do -8, 10, -5, 5, 9, -4, -1, 7, -3. Now we're going to do a Y, where we're going to switch the Y value with the target. So the X values stay the same. The Y values change, -8, 10, 5, -1, 7, -3. And now we're going to do the last one as A in terms of Z. This is where we're going to switch out the Z column. So we're going to have 2, 5, 9, 10, oops. 2, 4, -2, 9, 5, -4. And switching this column out, we end with -8, 10, -5. All right. And we want the determinants of all of these. Are we going to actually do them by hand? No, we are not. We're going to go to our favorite matrix calculator. Now, could you do this all by hand? Of course we could. Are we going to do that? No, that's not my plan. All right, so let's see here. We want a 3x3 matrix. And it is, let's see, 2. Oops, that's not 1. 2, 5, -1, then 4, 9, hardly see that. 4, 9, there we go. Ooh, that's much better. 4, 9, 7, -2, -4, -3. And we want the determinant of this matrix. So the determinant of this matrix is -10. So let's write that to the side. So determinant of A is -10. Okay. So now we're going to remove that first one. We're going to change that to be the target vector. It's going to be -8. It's going to change. This is going to be now 10. This is going to be -5. And we're finding the determinant of this. So this is the determinant in terms of X, which is -38. So determinant of A sub X is going to be -38. Then we're going to go back to the original and change the target on that. So we're trying to find the determinant of Y. -8. Let's see. 10, -5. determinant in terms of y is, let's see, 26. Okay. And then last but not least, we're going to find the determinant in terms of z. So determinant in terms of z, we're replacing that last row with the target, -8, 10, -5. Let's see what it is. -26. Isn't that helpful? So now here's what I'm going to do. I'm going to actually find out what the answer is by just putting our augmented matrix and reduced row echelon form, but I need a 3x4 matrix for that. Oops, that's not what I wanted to do. So let's see, 2, 5, -1. And oh, by the way, before I do that, let's state what we think x, y, and z are. So x would be determinant of x over determinant. So there'll be -38 over, I think it was 16. It's hard to read my own handwriting, which is the same thing as 17 over 8. For y, that would be 26 over 16, so 13 over 8, or -13 over 8. And then for z, to be -26 over -16, so +13/8. Let's see if it's right. So we're going to do, let's see, -8, then 4, 9, 7, 10, then -2, -4. Assuming that I did this right, -3, and -5. We should be getting the same values. Let's see. Oh, that must be a 10. Wait. Oh, Lord. That must be a 10. And my determinant of AX must be off. So let's see. 19, Ben, 19. That must be a 10 that I wrote. Determinant of A was 10, was -10, not -16. So let me fix that. Boom. 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 That's why we like to check, right? So let's see. That should be -10, which makes this, instead of being 8, that makes that 5. So it makes that +19 over 5, -13 over 5, and -13 over 5. This is a 10 and not a 6. Okay, that makes so much more sense. And yeah, 13 divided by 9 is, or divided by 2 is that. So then we plug in all of our stuff. -10 was a determinant, 26 was a determinant, -26 was a determinant, -38 was a determinant, 38. So x was equal to 19/5. Y was equal to -13 over 5. And z was equal to 13 over 5. And that's it, guys. All right. So that's how you do everything. Hope you guys found this video helpful. And if you have any other questions, I'm here for you.